So today we will understand how to set up Kubernetes cluster on AWS EC2 instances using Kubeadm method. Okay. So before understanding this method, okay, let's understand what are the various steps involved in this method and what has changed from the previous versions of Kubeadm. Okay. So we all know that Kubernetes deprecated Docker. Okay. Let's understand what is the meaning of this. To run containers in pods, we need a container runtime like Docker or containerd, rkt and all, which we already know. And Kubernetes works with all container runtimes. Okay, so earlier, prior to Kubernetes 1.20, ideally Docker also used to be supported by Kubernetes. Okay, so that's the reason why Kubernetes used to work with all container runtimes, and these container runtimes should implement a standard known as container runtime interface. Okay, so your uh, kubelets, basically the kubelets are the components responsible for talking to the container runtime. So basically the kubelets will talk to the container runtime interface, and this container runtime interface in turn will talk to the Docker or any container runtime to create containers. Okay, so what happened is, basically this is the standard method of communicating between the Kubernetes and the container runtime. And any runtime, if it has to be supported by Kubernetes, has to implement this CRA. Okay, but unfortunately, CRA, Docker doesn't implement this CRA directly. Okay, because Docker uses its own set of APIs and all. That's the reason what Kubernetes did is Kubernetes implemented a component known as Docker shim. Okay, so anyways, kubelet will talk to the CRA. Now CRA will talk to the Docker shim, and this Docker shim converts the calls to the APIs, which are which will be understood by the Docker. So this is an extra component known as Docker shim. Okay, understood. Then what Kubernetes realized is maintaining this extra piece of software called Docker shim to integrate Docker is of no use, because ultimately it needs only container runtime. Okay. So in case if you know about Docker, so Docker internally uses containerd as the container runtime. And on top of that, it has Docker volumes, Docker networks and all. So altogether, it is calling the whole package as Docker. Okay. But Kubernetes needs only containerd, because that's the container runtime, and container D actually implements the container runtime interface. So which means, so instead of directly talking to the Docker, so what we can do is we can let CRA talk to the container D directly. So this eliminates the need for maintaining Docker shim. Okay, so that's the reason why Kubernetes, in the recent version of Kubernetes, it completely deleted or made it unavailable in the current releases. Okay, so we don't get Docker shim if you install Kubernetes. Okay, that's the reason why if you use Docker, but if you don't use Docker shim, your Kubernetes cluster creation will fail. Okay, but what happens to the clusters which are already using Docker? Okay, since Kubernetes is not supporting Docker shim, so what Mirantis did is, Mirantis and Docker, they both decided to maintain this Docker shim project outside Kubernetes. Okay, so they took the source code maybe, and now they are calling it as CRI Docker T, that is container runtime interface for the Docker, and they're maintaining it as a separate project. Okay, now the CRI Docker D should be installed along with Kubernetes if you have Docker as a container runtime. Otherwise, if you directly have container D as a runtime, you don't have to install any CRI converters like this. Got it, guys? Okay.
Yes,
So this is the actual architecture. So if you see Kubernetes will use the CRI, and since Docker doesn't support it, we are using Docker shim, which used to be supported by Kubernetes, but Kubernetes stopped supporting. So in order for the kubelet to directly create, talk to the container runtime to create the containers, okay, so we are using containerd. Okay, so here containerd supports CRI, so it is easier now. Clear? That's the only requirement. So what we will do now is, so we will not install Docker. Instead, we will directly install containerd, that too using the hard method. we will not use any package managers like apt or yum to install that, because we will directly download the binaries, and then we'll see how to build that container d from the source code. Okay, so everything is clearly mentioned in the respective websites. Okay, and this cluster setup using Kubeadm is directly taken from the official Kubeadm documentation. Okay, so we'll have Linux compatible Linux host. We'll use at least 3 machines, one for master and 2 for worker nodes, and we should make sure that there is a connectivity between all the machines inside the cluster, and a unique host name for each of the nodes. And also some ports need to be open, because master components will talk to the slave components, the worker components, and worker components will talk to the master components. So that's the reason some ports needs to be open. Okay, and swap space should be disabled in all the machines. And since in Kubeadm all the components like the control plane components like API server, scheduler, controller, etcd will run as a pod. Okay, so we need to have container d or container runtime supported by Kubernetes to be installed on all the machines including the master nodes. Okay, now let's see the official method. uh, so we'll go to kubernetes.io. You can also directly search kubernetes.io kubeadm. Okay, so installing kubeadm, and this page mentions everything that are required to create the cluster using kubeadm. So we need compatible Linux host, at least 2 GB of RAM, and 2 CPUs are needed. So we will go for T2 medium in case of AWS EC2 instances, and unique host name for each node, and swap should be disabled. Okay, and if you see here, we need to also open some ports on each node. So I'm opening this link in the new tab. So on the control plane nodes, these ports should be opened, and on the worker nodes, these ports should be open, right? And if you go back here, we need to install a container runtime. Okay, so here container runtime should support CRI, container runtime interface. So I will open this in the new link. Okay, container runtimes. So these are all the container runtimes. So containerd, cryo, docker engine, and mirantes container runtime. Okay, so this is basically CRI docker d if you are planning to use docker. So let's click on this containerd. Okay, so this containerd can be installed using the instructions in this document. I'll open in the new tab. Okay, so there are two ways. So once you can install using package manager, or else you can download the source code and you can install it. Okay, so here they're asking us to download the official binaries. Okay, for your architecture. So what is our architecture? Our architecture is x86-64 AMD. Okay, so we will install that only. And then you need to also install RUNC and CNI plugins. Okay, so let's open them in separate tabs. Okay, now how to install containerd? So basically you need to download it, download the official tar file from the releases page. So I'm opening the releases page in the new tab. Okay, so this is containerd. So here I can go to the assets. So our architecture is AMD 64 Linux. Okay, so containerd Linux AMD 64. What we can do is we can right click, copy the link and link address, and then use wget to download that. Okay, so once that is downloaded, so what we can do is we can extract it to user local. Okay, and once that is installed, okay, so if you see, basically it uses system D. So for that we need to have the service file. So we can download the service file from here. Again, directly right click, copy the link address, and use wget to download, and then simply move it to this location. Once it is moved, you can reload the daemon and containerd will be enabled. After that, you should install RUNC. Okay, so that project I've opened in the new tab. Okay, so otherwise you can also directly follow the same link. So download the releases. So open this releases page. So this is the release page for RUNC. Just scroll through the assets. So we need RUNC for AMD 64, this one. Okay, again right click, get the link address, use wget to download. So once you download RUNC, simply run this command. So it will install RUNC. After that, you need to install CNI plugins. Okay, so you can download for your own version. So, okay, open the releases page, go to the assets. Okay, so here I need to select Linux AMD64, which is the first link itself. Right click and take the link. Okay, just copy the link and then use duplicate. That's it. Okay, so after that, you can create this directory, extract into that directory. Okay, so that's it. So here CNI will be installed. Okay, so what we did is we installed container D and then all the dependencies like RUNC and then CNI plugins. But how do you communicate to that container runtime? Right? That's the question, right? So Docker uses Docker tool, correct? Right, guys?
Yes, Vikram. Yes, Vikram.
So if I have a Docker daemon running here, and in the same machine, if I have Docker client tool, okay, Docker CLI tool, basically it uses a unique socket, okay, which is available under var run docker.sock. Okay, so it will be like this. So link will be like unique unix like this double slash and the proper location of the socket. Okay, so once you install any once you install Kubernetes, so usually it looks for all the container runtimes from the standard locations. Okay, so what are the standard locations? So var and docker.sock is one standard location. Okay, Kubernetes looks for that. And what once it finds a proper container runtime, so kubelet, which is basically the component responsible for talking to that container runtime, will take that particular link, okay, or the location of the socket file. But what are the various socket files available? So if you go to this container runtimes, installing Kubeadm method, so here there are standard socket files like Docker uses var run. Uh, See, what is the meaning of this? Why Docker engine? It is different now. Okay, so why it is not var run docker.sock?
Because you just told now that Martus and Docker, like
Yes. So
creating
here
the thing.
we don't have var and docker.sock. Okay, because here kubelet has to talk to the Docker, but here we now have, so earlier Docker shim used to be there. Now it is CRI Docker D. Okay, so they have their own unique socket. So if kubelet talk to that unique socket, it will talk to the Docker. Okay. Similarly, container D has var run containerd.sock. Okay, now this is the socket file that is used by containerd. Okay, so till now what we did, we installed containerd and we install RUNC and then CNI. Okay, and this is the socket that it will create. So var run container docker dot containerd.sock. So the client tool, okay, so whatever it is, whatever it may be, so the client tool will talk to that socket. So that socket means it is like talking to the container daemon. Okay, container d. Okay, so what is that client tool? So here it is CRI-CTL. Okay, this is a common tool, not dedicated for container d. It is CRI-CTL. Now CRI-CTL has to be installed. Okay, so once you install Docker, basically it installs Docker CLI plus Docker daemon. Okay, so we have installed only container D now. We need to install CRI-CTL. So that also it is given in the container D page only. Okay, if you go to the bottom, okay, so that container D can also be installed from apt. Okay, that link you can check. And then if you go to the bottom here, interacting with containerd via a CLI, there are a lot of CLIs. Okay, CTR nerd CTL is also there, CRI CTL is also there. So let's install the CRI CTL. So just open the new tab. From here you can install CRI CTL using wget. Directly download the binary, extract it and move into user local bin. That's it. Okay, your CRI-CTL will be installed. But here CRI-CTL doesn't know which socket to use. Okay, CRI-CTL has to use this particular socket. So for that we need to create a configuration. Okay, so that configuration will be read by CRI-CTL. Okay, if you scroll to the bottom, Okay, cractl can use this as the socket, containerd as the socket, cryo, container d, cra docker d, any socket it can support. Okay, but how do you configure is, so you need to create this cractl YAML file. Okay, and then runtime endpoint, you need to make sure that it points to the containerd.sock. Containerd.sock, if you want, you can get it from here. So this value has to be um, put here. Again, image endpoint also it should be there. Timeout, it's up to you. Debug, if you want to make it true, it is true, otherwise you can turn it off. That's it. So this config, once it is created, now you can use cractl commands. They are similar to docker. So if in docker, if you are using docker image ls for getting all the images, so now it is cractl image ls. That's it. So for docker file, I mean, to for building container images, you are using docker build, right? It is now cractl build or cractl ps, cractl ps hyphen a. Everything is same. Clear? Now once cractl is installed, okay, container D is installed. So our container runtime dependency is solved. So after that, we will proceed to installing Kubeadm, kubelet, and kubectl. Once these are installed, so see these instructions are also given here how to install. Okay, and once it is installed, you will proceed to using Kubeadm to the create a cluster. That is the next link. Then simply you would do Kubeadm init, and it also supports a lot of parameters like which API server address to use, or if you need a separate pod IP ranges, that is CIDR range, that also you can use. Okay, so there are many things you can configure. Then once you do Kubeadm minute, you will be asked to run some commands. Okay, so this is the command that will copy the configuration from a standard location, that is generator location, into your home directory under .q folder. The file is called config. So that is the configuration file for the kubectl basically, which allows you to talk to the API server. And after that, you need to deploy a pod networking solution. In our case, we will use VNet so that all pods get connected. Okay, and once this is done in the master node, so you want your slave nodes to join the cluster, that is connect back to the master. So it will Kubeadm will display this particular command, that is the join command. So run this join command in all the worker nodes, so all the worker nodes will now join the cluster. Okay, that's it. Okay, so I created this readme document under this YouTube series GitHub repository under Kubernetes cluster setup. There is this file called Kubernetes on AWS with containerd. So we will take three Ubuntu servers running Ubuntu 20.04 LTS. We'll use one for master and two for the worker nodes. Master nodes you can take T2 type, T2 medium type. Workers you can take T2 micro type. That is fine. And we will set all the we'll change all the host names using hostnamectl command. Okay, and then we will try to open some ports on the master node, some ports on the slave nodes, and then we will attach them as security groups to respective nodes. And then we'll try to run some commands on all the nodes. Okay, so for this we will launch instances. Okay, so we are in the EC2 instance, launch panel. Okay, so Kubernetes, I will create three instances. So you can create one T2 medium and two T2 micro type. Otherwise you can create all T2 medium and then delete the cluster once you are done. Okay, so we'll take Ubuntu. So Ubuntu 20.04. Okay, and then T2 micro, we'll select it as T2 medium. Key value, key pair, so let's create a new key pair. So we call it as K8s. Okay, it is already there. Let's say Kubeadm, and then create this. Just download this. Okay, and security group we will create and attach the security group later, right? And 8 GB sufficient. Let's click on launch instances. So while it is launching, let's try to create security groups. Okay, so that we can attach to the instances. Click on security groups, create a security group. So here I'm calling it as master. So I will write a description, creates master SSH, security group. Always make sure that when you're creating a security group, just use underscore and the object name you're creating. So this is the master, which is the name of security group. Underscore SG means it is a security group. In the inbound rules, we'll add inbound rules. So first we'll enable SSH, and then let's try to create some rules. So already I've shown you what are the open ports need to be open. So here these are the open ports. So 6443 TCP for the Kubernetes API server access, and the other one is 2379 and 2380 for the HCD. Let's open this. The other one is 6783 TCP, 6784 UDP for the VNet. Okay, so TCP this, and custom UDP 6784, and 10248 to 10260 for all the other components like control manager, kubelet and all. Let's select IPv for everywhere. And then 30,000 to 32767 for the node port services, because all the apps gets exposed only on this port. I'll talk about why this range is needed later. And some generic ports, if you need, you can also open like 80443, like that, 8080. That's it. So let's create this security group. And also, if you see this documentation, so here on the slave nodes, we should open these two ports, these, and same 30,000 to 32767. Okay, so almost these ports are also open on the master node. So instead of creating a separate security group for the slave with only these ports, for time being, we can also use the security group that is created for the master, because there are some common ports which are opened on the master node as well. Okay, so let's use the same security group for everything. Okay, now let's go to the EC2 instances. So let's try to rename them. So let's say this is master, slave 1, and slave. So select each instance, go to the actions, security, change security groups, remove the existing one, select master underscore SG, and then add it to the master. Similarly, do for all the slaves. Remove the existing one, select master underscore SG, same for slave 2. Okay, so security groups are all added, which means all the ports are open on all the nodes. So let's SSH into all these instances. So open MobaXterm. Let's create a separate folder. Right click on this blank place. So let's say K8s. Right click on this folder, new session, SSH. Now take the IP of the master and then specify username. So username is Ubuntu. Advanced SSH. Use private key. Just use the private key which you downloaded. Bookmark, just call it as master. Okay, so it is sshing. Let's close this, duplicate this, right click, edit. Okay, take slave 1 IP, public IPv4, copy paste here, bookmark, make it as slave 1 S1. So other configurations remain same because we are using same key pair, and then username is Ubuntu. Again, duplicate this S1, right click, edit, So now take the slave to IP, change it here in the bookmark, call it as S2. That's it. Okay, so now let's click on master. Okay, so if you see, so here we are unable to identify whether this is master or not. So let's become root, and let's use systemctl, sorry, hostname ctl, set hostname master. So this node will now have the host name as master. Enter. Okay, so it may not change immediately, but if you close this session and try to open it, so you will see that it is master. Okay, similarly do for the other slaves. Open slave 1, become root. Now hostname ctl. Okay, so if you're not sure, I've already copied all the commands here. So hostname ctl, set hostname slave 1. Okay, now close the slave 1 session, open s2, become root, hostname ctl, set hostname slave 02. Now can close the session. So let's open all three. Okay, go to multi-xcc mode. So you have master, slave 1, and slave 2 at the bottom. Just become root in all of this. Okay, now let's start the actual installation process. So first we need to disable swap on all the nodes. Okay, let's copy both the commands, go to the terminal, click on multi paste. Okay, so this should disable the swap, and then install the container runtime. Okay, so what we are doing is we just copied from the releases page. Okay, so this is a link to the container d, we took it from the releases page. If you're not sure, okay, so I don't think I have to show it again, but let's see for just one container example. Okay, so if you open the container runtimes container d, and then you can go to getting started with container d, and then go to the releases page. Okay, and here in the assets I will select this container d. So right click, and if you try to paste the IP, it is exactly that. Okay, understood guys? Let's cancel it and try to use the commands. So duplicate, we are downloading, and then we are extracting this tar file into user local. Okay, and once this is done, we know that we will have to uh, run this as systemd. Okay, so for that we have this link. If you try to open this link, it is basically a dot service file. Okay, so here units service and then install. Okay, it's a service file. We are actually downloading it and then creating a directory called user local bin systemd system. We will move that service file into that, and then once you reload the daemon, your container d should actually start. Okay, so let's do that. Okay, it says so there is no such file or directory. Okay, let's paste it again. Okay, now if I run systemctl status containerd, so my containerd is running. Okay, but as we know that after containerd you should also install runc. Okay, so let's install runc from this two commands. Okay, so that is installed. So if you want to know, so you can simply use runc, it should actually respond with something, right? After that, install cni, again download the binary. Okay, make directory opt cni bin and then extract it there. That's it. Okay, so we are doing it on all the nodes because container runtime should be present on all the nodes of the cluster. And after that we need to install crictl. So this version, duplicate the binary and then extract it into user local bin, and whatever tar file that you downloaded, you are simply removing it. That's it. All these are binaries. They need to be moved into the system binary paths. Okay. Even that is also done. If you try to run cractl, now it will respond with something. If I try to do cractl ps, it throws an error. Okay, so if you look at the individual screens, okay, let me run cractl ps again. So it says, it is trying to connect to an endpoint called dockershim.sock. It did not find. Okay, and then it tried to run this one. Okay, try to find a containerd from this location. Okay, uh, so here that is also not achieved. I mean, it didn't find that, but of course that is there. Okay, so if you look at slash run containerd.sock, it should be present on all the nodes. Okay, so it is there, but it's saying you should set that endpoint, otherwise cractl doesn't detect it. Okay, so for that what we will do, it's very simple. Okay, so we will create a file known as etc cractl yaml, and we put this content. Okay, and runtime endpoint will set it to containerd.sock. Image endpoint also same. Timeout is true, debug is set to false. Okay, if you make it to true, you'll get all the debugging information which is not required. Okay, and everything we are putting it in etc cractl.yaml. Okay, so if you use this, that file will be created. Otherwise, if you want to see, I'll create manually. Okay, so vi that file. Okay, it says some swap file is already there. So let's edit anyway. Go into insert mode, just paste this content. Click on multi paste and then exit with saving. Okay, it is saved. Now if you do cractl ps, now you will see that it is responding with container. So cractl ps. Okay, so containers, container processes. So cractl images. Okay, see there are no images yet. I can also pull the Docker image. So cractl pull or Docker pull, let's say nginx. So by default, it should go to, I think, Docker Hub to pull. Okay. See, image is up to date. So cractl images, you should see that nginx is downloaded, which means we now have a new container runtime called containerd, and container utility tool like Docker CLI tool. We have cractl tool. Okay, now let's go into multi-xcc. Now we have container runtime in all the machines. Okay, now what we have to do, we have to enable some IP tables. Okay, so again this is also directly taken from the official documentation. So let's run them. Okay, I'm just copying. Yeah, so it is here. So here this is in the container runtime section. Okay, so after container runtime, I think on top only it has this one, forwarding IPv4 and letting IP tables see bridge traffic. You have this whole thing. So I did the same thing. I just copied everything in one place. So let's run in all the three nodes. Okay, so that is also done. And after that, we need to install kubectl, kubelet, and kubeadm on all the nodes. So we are installing curl and then adding the gpg key. Okay, adding the Kubernetes sources list, that is a repository, right, guys? And then update, install kubelet, kubeadm, mark them as hold. Okay, so I pasted it twice here. So just copy the hold. Otherwise, you can also run individual commands. Let's install curl. Okay, so here it is not installed. So let's try to Okay, I think they are getting installed. Okay, so in all the machines now, I think it is installed. Now let's add the gpg key and also the repository and just update it. Guys, getting right? Any confusion?
No, Vikram.
So it says 404 not 4. Okay, let's proceed. Install kubelet, kubectl and kubeadm. Unable to locate package, which means the repository is not added properly. Okay, so let's check it in master node once. Let's add this repository properly and then apt update -y. Okay, and then install. I think the commands are not executed properly. Okay, so now it is installing. So let's repeat the same process on the other nodes as well. Okay, this is in the slave 2. So master node it is done. Slave 1 and 2 it is. Slave 1 is also done. Okay, so these are also installed. Go into multi-xcc, run this hold command. Okay, okay, so if they are giving errors, just run them again. Okay, because we are continuously downloading the files. Maybe apt tool must be busy. Okay, so now all the prerequisites are met. Let's log in only into the master node. Okay, so in the master node we have to pull all the images and then run Kubeadm in it. So let's try to pull all the container images for Kubeadm. Okay, so your API server, scheduler, controller, HCD, everything will be downloaded. So the next command Kubeadm init actually has lot of flags. Okay, so if you have multiple IP addresses, you can choose which IP address that API server should use internally. Okay, so if I run Kubeadm init -help, you should get all the flags. Okay, so you can explore all the flags later. So main important flags are this API server advertise address. Okay, so here let's say that basically your master node, okay, basically has, let's say, three networking interfaces. So one has IP address of this, one has something as this, some has IP address of this. Okay, so always master node will listen on 6443. Okay, but your slaves, okay, so they need to contact your master to join the cluster. Okay, so they use 443 port while they are connecting, that is fine, but what at what IP address? So your master is running on what IP address? Okay, so if it has it, if it is you if your system has only one networking interface, automatically that will be selected. But if you have multiple, so you need to give that option, like you need to pass that IP address to the master, so it starts listening on that particular IP address. So if I want this, so I have a flag called API server advertise IP address something. So you need to use that IP address. Now that IP address will be used by master to run the API server. Okay, so now the slaves will use that IP colon 6443 to uniquely identify the master node. Okay, so that is the API server advertise address. Okay, and also you have pod networking interface, uh, pod cider range, not networking interface, sorry, pod cider range. Okay, so if you want to use different runtime, okay, so then you can pass this runtime socket as an argument. Okay, and then you can also install a specific version of Kubernetes. So there are a lot of things that are available. Okay, I am simply doing Kubeadm minute. Okay, so it will take all the defaults and the default networking interface. Okay,
Vikram,
yeah,
yeah, when you told the different networks, so you are talking about the NICs, right?
correct. Nick cuts.
Okay, which is like by default we explicitly attach in AWS
To
or Azure
the
or GCP.
this ECP. Correct.
Okay,
Since we only
okay,
have internally one network, so if you do if config anywhere, you will get only one IP address,
very
right? That's
correct.
the reason
Yeah.
it will automatically select. Now your Kubernetes control plane has initiated successfully. Okay, so here in order to start using the cluster, basically cluster creates a config file. Okay, so let me draw a simple diagram. So you have the Kubernetes API server running in the master node. Okay, so the master node, the API server is the entry point. So the API server, your utilities like kubectl utility or any third party external UI tools, they have to talk to the API server. But kubectl tool, how it finds this API server. Okay, so in case of Docker CLI, okay, so Docker CLI will use that unique socket which is available in the standard location to talk to the Docker daemon. Okay, so here it is not unique socket. Okay, so API server is listening on some IP address and 6443 as the port, and your tools. Okay, so they need to use this IP address and proper parameters to uniquely to talk to the API server. Okay, so for this, what cluster will do is cluster will generate a config file. Okay, so there are three standard locations for this config file which we'll see later. Okay, so kubectl utility will basically try to find this config file from all three standard locations. If the file is located in all three standard locations, it will merge them together, and ultimately kubectl will talk to this config file. Inside this config file, you'll have the IP address and port number of the API server. So this kubectl will read that information and it will talk. Okay, so when you're trying to create the cluster, um, you know that configuration file will be located here, admin.conf. So that needs to be sent to this location, I mean copied to this location. Okay, so why this location is, um, I'll talk about later. Basically, that config file should be located under your user home directory in case of your EC2 user. So it will be generated under this .q folder, a file called config. In case you're running as root, it will be under /root .q and config file. So your kubectl will try to read the file from this location. That's why when it is generated in this location, okay, you need to copy it, and also you need to change the permission so that only you will be able to use it, other users will not be able to use it. That's why ownership permissions has to be changed. Okay, and also it is clearly given to start using the cluster you need to run as a regular user. Why regular user is, okay, so if ubuntu user has to talk to basically the cluster, that configuration file should be available under his home directory. Okay, so you can become normal user and run. Otherwise, if you are planning to run it or from the root user login, then you run it as a root user. I run it as a root user. Okay, so once this is done, so I can use kubectl. So this is the first time we are running this kubectl command. So let me get the list of nodes using kubectl get nodes. Now if you see, we have only one master node and still it is not ready. Okay, so what we need to do now is, after this we need to basically deploy a pod networking and what do you say, the pod networking. So the link is given here. So there are variety of networking solutions that we already know. Okay, Calico, Cilium, VNet, Flannel. Okay, so if you go to VNet website, so installing, if we go to the installation, so this is the link that they gave. Okay, so we can take this link and then use kubectl apply as an input file. I am giving the URL. That's it. Kubectl apply -f. If you want, you can also take that reference from here. Okay. So here, okay. So I gave this two times kubectl apply -f. So now your pod networking is installed. So in my case, I installed VNet. Your cloud providers will use their own set of pod networking interfaces. Now let's do kubectl get node to see the list of nodes. If you see now, your master node is in the ready state. The master node becomes the control plane node, and the version it is running is Kubernetes 1.26 26.1, which is pretty new. Okay, I mean it's the latest one. Now how do I join my worker nodes? So here Kubeadm will give you a join token, and this is the IP address of the master node, and 6443 is the port on which your API server is running. See here, there is only one networking interface. That's why Kubeadm init without any argument just took this IP address. So if you have multiple NIC cards interfaces, then pass that the IP address which you want to be used as the identification. So let's take this, okay, and then go to the slaves, run it, in all the slaves, okay. uh, let's run it again. So there is some error, let's fix it. Okay, see here, this s1, this node has joined the cluster. Okay, now if I go back to the master node, because in master node only I have this kube config file, that's why kubectl will run it, use that file. Now if you see, I got slave 2. Okay, so slave 2, okay, did I run two times? So this is slave 2, this is slave 2. Oh, okay, both the nodes are slave 2s. That means we did we make a mistake anywhere? Let's click on slave 1. Oh, okay, so this is also named as slave 2. Okay, even slave 1 is named as slave 2. Okay, let's quickly change it. um Hostname ctl, set hostname. I think we forgot, but that's fine. Okay, it's not an issue. Let's run it as root. Okay, it is saved. Okay, so let's open slave 1 again. Okay, now if you go to master node, uh, I'm not sure whether it will. Okay, we are not sure, but it is not changed, but that's fine. Okay, now coming to the actual slave to node, it is giving some errors with Kubeadm join token. Let's see why it is giving the error. So it says, okay, it is giving some issues. Okay, what I will do now is, here I'll do Kubeadm reset. I'm resetting this particular node so that everything will be removed, and then I will try to join it back. Okay, in case if you are stuck somewhere and you pressed Control C, so when you do Kubeadm join again, it will say that some files are already there. Okay, so in order to reset them, just use Kubeadm minute. Clear? Now this node also joined the cluster. Now if you go to master node and do kubectl get nodes, okay, see here, there are two nodes. Okay, of course, we did a mistake with naming initially, but that's fine. Now we have three nodes. Understood, guys? Now we can close the nodes because slave nodes join the cluster. Any questions, guys?
No, Mitra.
Okay, so now we have three nodes. One is master and two are slaves. Okay, so I'll explain about the kubeconfig file in the next session. But how do you verify the setup? So if you go back to the documentation, so here, we listed all the nodes using this command. Now I can list all the pods using kubectl get pods. Okay, so there is a shortcut called po. Okay, so there are no pods in the default namespace because all the Kubernetes masternode components are are kept in a separate namespace, which is directly not accessible. But if I have to get all the pods inside the cluster from all the namespaces, I can use hyphen capital A or hyphen hyphen all namespaces. Again, all the shortcuts and all we'll see later. Now you can see here, we have core DNS, HCD, API server, control manager, kube proxy, scheduler, VNet, that is pod networking. So everything is running as a pod, okay, in the cluster. And this output, the ready status, restarts, age, namespace, we'll cover it in the sessions, okay. And in order to test this setup, what we will do is we'll try to deploy a simple Nginx pod, okay. So kubectl run will create a pod. The pod name is nginx. It will use nginx image and port 80 will be exposed. Okay. And in order to access this application from outside, we are actually exposing the pod by the name nginx because the nginx is the name on node port. Okay. So what is the meaning of this is, a port between 30,000 to 32767, which we used. So a random port will be selected and assigned for Nginx. Now, in order to access Nginx, we can use that port. Okay. So we deploy two components. So one is the pod and the other is the service. So service you can use like this, or there is a shortcut called SVC. And if you see, this is the Kubernetes internal service, which we don't have to worry. I'll explain later. Now, Nginx is on node port, and this is the port 32010. So now, on what IP address I can actually access this port on 32010? So you can take any node IP, master, slave, slave one, slave two, anything. So if you take slave two, just copy the slave to IP. That application is accessible on 32010. Let's see what is the port. 32010. Let's see whether in the security groups. Okay, it is already open. And let's see the status of service, status of pod is in the running state. Service is 32010. That is also correct. Let me take the master IP once. Yeah, 32010. It is opening on master IP. The slave IP should also work. So this is the slave 1 IP. It is also working. Slave 2. Just change the slave to IP. 32010 is common. Okay, so this is not working. Okay, so I'm assuming there is some issue with the networking which we experienced right when creating this. Okay, so we got lot of issues because we didn't give proper naming conventions. Okay, maybe some components were not installed. That's fine. Okay, even though it is in the ready state, maybe it is not accessible. That is fine. Okay, but if you're doing it perfectly from scratch, even that IP should also work. See here, slave 2 is not ready. Okay, that is the issue because we did not properly set it up because we took two nodes with the same names. Okay, so that created this issue. Okay, that's fine. Okay, so kubectl get nodes. Okay, So this is not in the ready state. That's the reason. Any questions, guys? And of course, you can also, you know, if you are outputting the wide format output, okay, you can also see slave to what is the IP address. Okay, see here. Okay, the issue is the IP address is same. That means even though we have two instances, we actually used only one instance. That means we did not even touch the other instance. Okay, got it? Maybe we opened two common sessions thinking that both are different. That's the reason, but that's fine. Okay, if you do it carefully, even this node will come up. Okay, so this is the issue that we that this is the issue actually. Any questions, guys? Okay, so try to name them properly and check again whether all three nodes are different and then set the cluster. Okay, clear?
Yes, Vikram.
Yeah. uh, so node to delete it, we will not have that problem now. Okay, just make sure that three instances are different, then you will have three instances.